Hi, everyone, and welcome to those in the room and also people at home. The name of our webinar today is Uncorking the Effects of Alcohol on the Brain, and it's the fourth in a series of 5 webinars for Brain Awareness Week that is being hosted by the wonderful Brain Foundation. And so thank you to members of the Brain Foundation that have come along today to help us with the talk. I'd also like to thank in advance my team who have been helping with technical issues and also getting this presentation prepared. My name is Greg Sutherland and I am a researcher at the University of Sydney. My group's name is Sydney Brainomics. And I just also, before starting, want to acknowledge that the Camperdown campus, which we're on at the moment or broadcasting from, is on lands of the Gadigal people, the Eora Nation, and I acknowledge their leaders, past and present. Quick disclaimer, I'm not a medical practitioner, I'm a research scientist, so if people do have particular questions about or clinical issues, I won't be able to give them tailored advice. I'll also bring your attention to the QR code on the pillars within the room, and that's an opportunity to put your questions into our chat. And at the conclusion of my talk and a video that's been created by my team to explain a little bit about what we do at the University of Sydney better, we're going to have a Q&A session. So, alcohol and the human race has got quite a long history. And you may read, putting things into ChatGPT and the like, that one of the reasons that alcohol, and particularly beer, it should be beer, not deer, became very popular was because in medieval times we had such poor water quality. And there is some truth in that. It may, on occasion, particularly in built-up cities, and you use London as an example, in the 1400s and 1500s, there was a problem with polluted water, and people may have felt more safe with beer, but it's probably better to say that they drank beer and took their chances with water. But the history of drinking, or at least the history of organised alcohol production, goes back way further than that, and probably 6,000 to 7,000 years ago in China, and also in Egypt and Mesopotamia. And I would imagine, given that animals in Africa famously, including elephants, get drunk on fermented marula berries, that ancestors way back would have been aware of the effects of alcohol. Now, we have a long relationship. We also have this kind of yin and yang relationship with alcohol. We use it as a social lubricant. It's at least in Australia, it is very pervasive within our lives. And you will also read that there are health benefits associated with drinking alcohol, at least health benefits associated with drinking small amounts of alcohol. I've put up 2 adverts here. Both of these, funnily enough, one is produced by the Beer Council of Australia and the other one by the Wine Council of South Australia. So you kind of have to look at this with a pinch of salt, or at least a good degree of skepticism. But nevertheless, and there is reasonable data around that drinking alcohol or moderate amounts can have health benefits. And I suppose one that I'm aware of because of my own family history of heart disease is the recommendation of having a glass of red wine once a day to lessen your risk of heart disease. And you can see other diseases there that have been talked about, including lowering the risk of cancer. Okay, so is alcohol good for you? Well, potentially. So before going on to understand sort of alcohol, I want to, so that we're all talking about the same thing, I want to just give an idea of this of standard drinks and what that means. But if I draw your attention to the full strength beer, because no one in the room or in Australia would dare drink light beer or mid strength, then our cans are around about 340 mils, and that equates to 14 grams of alcohol for a full strength beer. Standard drinks are usually 10 grams of alcohol, so one beer can is 14. And so that when you see the drinks, that gives you an eye of what I'm going to recommend with the guidelines. You can get an idea of how much you're sort of allowed to drink each day to remain within the Australian guidelines. And then, of course, as you would be aware, the wines, and particularly fortified wines, sort of go up from there, with spirits right at the top of the tree in terms of bang for your milliliter. Mm-hmm. And these are the Australian guidelines, and they're produced by the NHMRC, and they suggest on a weekly basis that adults, and this lends itself, well, it's the collection between males and females, because there are slight differences in recommendations, should have no more than 10 drinks a week, or alternatively no more than 4 standard drinks in a single day. So that's talking around about 3 cans of beer. And as you might imagine, there's a number of us who probably exceed this, but hopefully only on a day-by-day basis. The guidelines have been modified since around about 2020 to include also that if you are below 18 years of age, or you are trying to conceive, or indeed know that you have conceived, and particularly in the first few weeks of pregnancy, you shouldn't have alcohol at all. The second point, or point 3 there, about people who are trying to conceive or have just conceived, the issue there is something called fetal alcohol syndrome. And I'm not going to go on about that anymore in today's lecture. I'm going to concentrate more on the effects on the adult brain, but I can talk to people about that in Q&A if the subject does come up. And with reference of children and up to 18 years, there's a couple of issues there. One, sort of legal in terms of your status as an adult and free will, but there's also an acknowledgement that the young brain, and particularly the young human brain, is developing probably onwards of at least 18 years, probably towards 25 years of age. And alcohol is not good for brain development. So what are the patterns of drinking in Australia? Those are the guidelines. Well, it turns out that at least most of us are drinking within those guidelines, although there is a reasonable, at least a quarter of us that exceed them on a pretty regular basis. And 2 points to take out of this pattern of drinking slide is that in outer regional and remote areas, that figure goes up to close to a third of people who are drinking in what is described as risky levels of alcohol. And the other thing to draw your attention to on the bar graph, or the histogram that's on the right-hand side, is that in Australia, for most age groups, drinking's actually gone down, except for the 60 to 69 age group. And this may have something to do with retirement, and I won't mention the boredom, but also it may have something to do with how we're organising that particular age group, or retirees now, around age homes, or independent living within age homes, and sort of these sundowners that can happen late in the afternoon, although that's conjecture on my behalf. Nevertheless, the intersection of ageing and alcohol consumption is a bit of a problem that I can, again, talk about a little bit more in the Q&A. One of the things that the Brain Foundation wanted me to talk a little bit about is that we know, particularly young people, that they tend to binge drink, and that idea of maximum of 4 beers on one occasion, then people would maybe drink that in the first half an hour just to warm up at a pub or a college. Not University of Sydney, of course. Our colleges would never indulge in anything like this. And they asked me whether someone who just drinks at home, glass of wine or 2 or 3 glasses of wine each day, how does that differ with binge drinking? If someone's just on a monthly basis, just really going, for lack of a better word, going hard. Well, probably in terms of the subject and of today and effects on the brain, it's relatively equivalent. There is some evidence that if your blood alcohol level gets to levels above 0.08, then there will be more damage to your brain than if you were just a chronic low level drinker. But the other points about binge drinking is that, and you can see on the histogram again, that it's the age of people that are involved in binge drinking. They tend to be very young, so that adolescent brain is still developing. And there's also quite a high risk of alcohol poisoning. And I'm going to show some figures about what levels you need to be drinking to move into that stage in a slide or two. Just as an aside, binge drinking probably 10 years ago used to be mainly associated with males, and in Australia probably associated with sport or the Mad Monday phenomenon. We're now seeing a lot of young women involved more. So I don't have the graph, but there's an intersection between females and males in terms of risky drinking. And again, some of the ideas around preloading prior to going to raves, etc., where spirits are quite expensive. So yeah, some changing lifestyles in Australia, which is changing our relationship with alcohol. So I raised the question, is alcohol good for you? Now I'm going to raise the opposite question, is alcohol bad for you? And maybe most people in the room are going to think that I'll come down on the side of it being bad. And probably this is the case. It's just how many different ways it's bad for you. And so we can look at sort of the social issues, we can look at direct health issues, and we can look at on the home front. And all of these obviously in themselves have some problems. Now, drinking and driving, I've just compared Australia with a few other countries here. South Africa, as you can see, is way up the top. And I don't know if anyone is from South Africa here, but if you have visited South Africa, you probably have some reasonably good ideas of why that might be the case. Again, I can talk a little bit about that if someone was interested. But Australia is right up there in fourth, and also compare it with, say, a similar population down with the UK. So we do have a lot of problems with drinking and driving. We also have a lot of problems with alcohol-related hospitalisations. Those figures there, although they do look large, really equate to about 5% of hospitalisations on a daily basis, or at least non-elective hospitalisations. Australia has about 34,500 hospitalisations on a day-by-day basis. So that puts it in perspective, but also if you want to have a look at 430 cases today and compare it with those related to sport, and for cyclists out there, we are the most likely to be hospitalised, it's 170. So it's somewhere between 2 and 3 times the amount of people hospitalised for sport-related injuries that are for alcohol-related injuries. And as you would imagine, there's a large cost associated with this. Not only the road there's direct and there's also indirect costs, including crime. And other than smoking, and I now would say of Western diets, it's probably the third biggest burden on our health system is drinking or excessive drinking of alcohol. So why does alcohol have these effects or bad effects on its health? Well, it's actually reasonably complex. Alcohol or ethanol, the chemical, is actually quite a unique chemical in that it's equally at home in water and in fats and oils. So it is able to just diffuse completely across membranes and go into all of our cells. And in that way, it's very similar to general anaesthetics. effect on the brain. They are just absorbed in extremely rapidly, and hence the effect on the brain. But over time, it also affects just about every other system in the body. And in some ways, alcohol has become more of a villain as we have stopped smoking. So smoking used to be the major risk factor for, well, it still is for lung cancer, but also for throat and esophageal cancer. With the decrease in smoking, we've now seen the rise of alcohol as a major problem in cancer risk. And again, some family background for me. Our family has been affected by rectal cancer, and I think alcohol could have played a part there. But I really want to focus on the neurological aspects of chronic alcohol for the rest of the talk. As I said, the NHMRC have put out guidelines, and they think that if you're an adult over 18 years of age, there is a safe level of drinking, and those were on a daily basis or on a weekly basis. They suggest if you're under 18 or you're looking to conceive or have in the early stages of pregnancy, that you shouldn't drink at all. However, the World Health Organization, or at least its European Union, has gone one step further, and it believes that there is actually no safe level of alcohol consumption. And we may find that Australia falls into line with that. Now, whether America does, having withdrawn itself from the WHO, I don't know. But this could be a sign of things to come, where those guidelines go voluntary, but we're probably suggesting that there is no level of safe drinking. Okay, so the effects on the brain. We're all familiar with the short-term effects. And then I wanted to bring back to that earlier slide where I was talking about binge drinking and get an idea of what some people who are binge drinking, what levels of blood alcohol they get up to. And generally, if you were to have, well, generally speaking, a young male who had eight beers, you're going to get up to about 0.1 or 0.2% blood alcohol concentration. So your blood is now, or at least 0.1% of your blood is pure alcohol. And you can see that already at that stage, you've lost coordination and you've got impaired motor skills. I'll return to that. But then it's not too much more if you were to triple that, and these sort of drinking binge sessions do happen where you start having blackouts because, of course, one of the major effects of alcohol is its sedative effects. And from there, if you continue to drinking or your blood alcohol levels spike, you'll start to get semi-comatose and then go to full coma, into a full coma, and eventually you will die if you continue to drink. And unfortunately, we do see these sort of situations all too often, particularly with young people. Reaction time is one of the real major problems, and of course it is a major problem when it comes to car or motor vehicle accidents. And so if we, again, looking at the bottom of the x-axis on the graph, or the line graph right down the bottom on the right-hand side, you can see that there is this association with alcohol level and longer reaction times. And it's not hard to see why alcohol is involved in so many traffic accidents, that people may just get the message from their brain to their foot a little bit too late to hit the brakes, for want of a better word. These levels are actually alcohol in the breath, and I won't talk too much about how you convert from blood alcohol levels, but this one is actually reasonably high. It kind of equates to 1%, so you would have to drink quite a lot. So it's really this area here, this area down here in this graph that's probably more pertinent to most people drinking moderate and even heavier levels. Just coming across to the left-hand side, because we're going to return to this point, is that alcohol essentially, and I talked about being a sedative, what it does in the brain is it tends to increase or stop your inhibition and increase excitation. It doesn't. It does that initially, and then it works in the opposite direction. It's got a reputation as quite a dirty drug, which attacks just about all of our different neurotransmitter symptoms. But it primarily binds to an inhibitory receptor called the GABAergic, and so its sedative effects, very like benzodiazepines, Valium, is through this boosting inhibitory neuron activity, and therefore we rapidly move from that kind of euphoria that you might see up within the half an hour or an hour of starting to drink into a very sleepy phase. And as I said before, if you continue to drink, you can move from sleepy into semi-comatose. The long-term effects on the brain is where my group research. And so looking at the pyramid there, you can see that for most people, or at least most people in the world, or at least half of the people in the world are non-drinkers. But in a country like Australia, most people indulge in pretty low-risk alcohol consumption. But right up in the top is a psychiatric condition which has been called alcoholism in the past, alcohol addiction, but its latest nomenclature, which is the DSM-5, describes it as alcohol dependence. So these are individuals who are addicted to the euphoric effects of alcohol, but for some reason their brain changes and they continue to need more alcohol to find those euphoric effects. The other part of that picture is that their dependence on alcohol is difficult to rid themselves of, because if they do go cold turkey or abstain, they go into withdrawal symptoms, and those are not particularly nice. And in fact, when people go into a hospital or a drug and alcohol clinic, they tend to use, as I was talking about, Valium-like drugs to actually keep those people who are going through withdrawal from not going into seizures, etc. So it is quite a difficult thing to get away from alcohol. The biggest question in alcohol use disorder research is that, why is it if two people start as social drinkers, one remains a social drinker for their whole life, but another person becomes addicted? And that is, as I say, the major question, and it's the question that my group are interested in trying to answer. What are the causes of alcohol use disorder? Well, I maybe facetiously sometimes, because we often in my group compare alcohol use disorder with Alzheimer's disease as another disease that we focus on. And we all talk about, well, we don't know what necessarily causes Alzheimer's disease. We definitely know what causes alcohol. And indeed, as I'm going to talk about, if you do not drink alcohol or you've never been exposed to alcohol, it doesn't matter so much whether you have a predisposition to it, a genetic predisposition. You will obviously not become an alcoholic. Similarly, if you stop alcohol, abstain, even though I said that's really difficult, you have the ability to, at least in partially, to actually repair your brain. And that's a really interesting and exciting part of the whole alcohol world, because that's quite unusual amongst the neurodegenerative diseases. What makes alcohol drinking more difficult for people like myself, who are generally reductionists in their thinking, is that there are motivations for why people drink, and often people drink and then are able to stop or quit, and that tends to be cold turkey as opposed to being able to get down to social levels. And then there's a psychological problem, there's trauma in their life associated with their family or something, and that kicks them off again. So it's addiction, and the changes in the brain are very, very, what we use the term heterogeneous, but very different depending on the individual. And someone that isn't an addict over their whole life, they go through this sort of waves and troughs. which makes trying to treat the disease particularly difficult. And then the factor in the middle is the social lubrication. One of our fundamental requirements of being a human is that we want to be socially, let me go as far as to say, accepted. And that helps a lot of people to reduce that inhibition and that social anxiety. And just like being in an aircraft at 38,000 feet and thinking you might have that second vodka with your Red Bull, a lot of people do suffer with social anxiety, particularly if they have to stand up in the room of their peers and give a talk on a subject. Okay, so long-term effects of alcohol on the brain, what's happening? From an addiction point of view, there's cellular changes, and particularly what we think is happening is that the receptors, and I've shown a few of those down the bottom here, the dopamine receptors actually get down, decrease in number, meaning that to get the euphoria associated with alcohol, that disinhibition, that pleasure, you need to drink more alcohol. And the reverse is also true when you stop drinking alcohol. You go through a world of pain, but it's also quite complex because there is other neurotransmitters involved. The other thing, and probably what we concentrate on as much, is what happens with metabolism of alcohol in the brain and elsewhere in the liver, because that has a toxic effect on the brain. And particularly, as I'm going to talk about, one type of brain cell called oligodendrocytes. Sorry, I've gone a bit too far. So this is the idea of what we would call the dopamine hypothesis of addiction. So people who are not drinking or not addicted to alcohol can, through one or two drinks, get the effects, and there is no need for them to try to drink to excessive levels to achieve that type of effect. They have a normal operating reward system in their brain, and the main neurotransmitter associated with our reward system is dopamine. But if you're an alcoholic, as I said, the dopamine system gets out of whack, particularly in 4 or 5 areas of the brain which make up our reward system, and people cannot get the reward or to satisfactory levels without drinking a lot more. And that you could supplement alcohol for cocaine, for other drugs, and a big problem in the world becoming opioids and things like fentanyl. All of them tend to, or we think they all operate in a very similar way by changing the brain, changing the brain's receptors, and in most cases down-regulating them, so you need more to get the same thrill. What we tend to look at and how we look at this disease is from a point of view of neuropathology. So coming back again to the ideas, what you will read if you put into Google, which is now running on an AI engine, and you said, what are the chronic effects of alcohol? What it's going to come back and says, alcohol shrinks your brain and kills off your neurons. Well, it does shrink your brain, but work from my group and others have shown that it doesn't tend to kill off neurons. And if it does, that's a very selective process. And I've talked about a couple of areas of the brain where that happens. But we think more of the problem is actually the loss of white matter. I'll talk a little bit more about white matter. And that idea of losing white matter has actually been also shown with neuroimaging studies. So yes, there is shrinkage of the brain. And for most of our brain, which is called our frontal cortex or cerebrum, made up of grey matter and white matter, it's actually the underlying white matter rather than the grey matter where the neurons are that is shrinking. And it's probably shrinking because we're losing a substance called myelin. And that myelin's a fatty substance in the brain, and it's made by cells called oligodendrocytes. But there is also a good news story here, because the same people who did those imaging studies also showed that if someone abstains from alcohol, like on the lower left-hand image, for over a period of a year, they start to get recovery of their white matter. The easiest way to see shrinkage in a brain or recovery from shrinkage is actually to look at ventricles which contain cerebrospinal fluid. Black or fluid on an MRI scan, or most sequences, actually shows up very black. And what you can see is that when that person had just stopped drinking, those ventricles are quite large, but after a year of abstinence, they've actually narrowed down quite considerably back to normal, and that's largely because the white matter is recovering. So leading into the last bit of what I wanted to talk about today, my group is very much wanting to understand what is the basis for the white matter loss and also the recovery. And we are interested not only because we think that this is going to be a way for people who have alcohol use disorder to offset changes to their brain, which are problematic for them through their daily living activities, but also we think it could be more generalisable out to other diseases that feature white matter loss. This includes multiple sclerosis, but also to Alzheimer's disease, which is regarded as a sort of a neuron loss disease. We do that in two ways, and I'm just going to give you a quick flavour of how we do this. And the person that leads a lot of this work in my group, Kane Smith, is here with us today. So lipidomics, what we're talking about here is that we take the brain, we mush it up to form a homogenate, and then we use mass spectrometry to try to work out the individual lipids that are in the brain. And there's many classes of lipids. But Kane's work has been able to show that in the myelin, and particularly in the areas where we know is either associated with the reward pathway, or we think the changes that people with alcohol use disorder undergo in terms of their working memory, like the prefrontal cortex, we're starting to see those changes as opposed to different areas of the brain. Just down on the bottom here is just a reminder, or for you who may not have heard of them, oligodendrocytes are the cells that produce the myelin that wrap around neurons, or the neuron communications called axons, that run from different areas of the brain, but also down into the spinal cord. And it's when you start losing those oligodendrocytes, you lose the myelination, you lose the insulation, and you lose the speed of transmission. And so you start seeing people with problems with balance, but also problems with their working memory and attention. The other thing that we have done, and one of my PhD students, Hal, is in the room at the moment, and he has perfected some of these beautiful images that you see on the left-hand side, is we look at building atlases. So in the old days, we would, if we wanted to look at neurons, we would use a single marker. But with the advent of being able to use multiple markers in the same section, we can now look at all the cells together in the brain at exactly the same time, and not only look at them, but we can count them, and we can also work out their spatial relationships to each other. And we do all of that, and we've just had this paper out in the last 6 months where we think that it's the small immune-related cells in the brain of people with alcohol use disorder that are the most problematic, and there is probably an increase in those microglia. And if not an absolute increase, we do think that their behaviour is changing, and that's kind of where our research is going over the next 1 to 2 years. As I said, we work on human brain tissue, which is quite different to a lot of researchers who use animal models. It's not that we don't use animal models, but my group main reason is main toolbox is using human post-mortem brain tissue. I'm going to go and talk a little bit about that now. Where do we get it from? Well, my other hat that I wear is as the director of a post-mortem human brain bank, and that human brain bank is actually about 50 metres from here on this level of the Charles Perkins Centre. So half of my team actually run a brain bank, and then the other members of the team work with that tissue. In essence, we work pretty closely together. The CPC is up on the left-hand side there, and I'm just showing on the large image there how we keep half of the brain tissue. That's in -80 freezers. So we have a biobank in the basement of the building. So that's one of our team down in the bottom of this building. And then on the left-hand side is just showing some of our research students plus brain bank members looking at sections and doing counting and very interesting things like that. A brain bank operates like this. This is the BTRC or our brain bank, how it goes. And the main thing to take from this slide is we are really dependent on volunteers who enrol as donors. And I believe we have maybe some of our lovely volunteers in the audience and online with us at the moment. And then this flow chart here just shows you what happens with that brain tissue. And I want to point out right down the bottom of the dissemination of the tissue, we're funded, or the brain bank is funded by the NIH in the US, and a lot of our tissue actually goes to the US. So human tissue from Australia that's going to probably, or almost certainly, the best researchers in the world, and we are able to disseminate it worldwide to make sure that the best brains are thinking about how alcohol affects our brains. And so, kind of wrapping up the talk, the big selling point for this is whether you have heard of brain donation and whether you might consider it. And I've gone with the "we want you." You might be thinking the Straits of Hormuz at the moment, and as old Uncle Sam, who started that particular thing in the First World War. But no, I spend a lot of my time through going on things like The Conversation or being a guest for the Brain Foundation on their webinars, trying to encourage people to think about brain donation. This is not organ donation. For transplant, this is quite a distinct thing, and people do get confused about this. So what we want to do later, and with my team, is talk to everyone about brain donation and the possibilities. And who you're going to call, for those people who may be from the 80s and remember Ray Parker Jr., we don't want you to call Ghostbusters unless you have got a specific problem. And it could be related to drinking too much. But we'd like you to call using our brains, and these are some of our contact here. So lastly, thanks for your interest today. These are our partner organisations. As I said, we're funded by one of the institutes at NIH, and we're really grateful for that. We're also helped by the University of Sydney. They provide all of the facilities for us. And I want to make a big shout out to our major partner, the Brain Foundation, who not only support us as a brain bank and our work, but support all of the 4 brain banks that operate in Australia. And if you forget some of the contacts I've given you today, you can go onto the website because they are big promoters of brain donation themselves. Before we have a Q&A, I'm going to ask my colleague and part of the brain bank team, Kane, to come up, because he's actually got a special and very highly creative video that he's going to show you that demonstrates a little bit more about what we do as a brain bank.
All right, thank you, Greg. Yes, as Greg just said, if you have any questions, if you can just ask them on the QR code. There's one on each column, and also a small link here on the slides. Now, there's been a little bit of just interest through our emails with what do we mean by, sorry. A little bit of interest by what do we mean by biobanking tissue and what happens to the brain tissue when you do donate your brain. So this is a very stylized, high-level overview of that process. So we just have a jelly brain, so it's not a real brain. And it's just a very brief kind of overview which I'll kind of talk through this video with what happens from receipt of your donated brain. So this again, is just a jelly brain, okay, walking through our lab just up here on level 6. And once we receive the brain, we hemisect it, right? So this is essentially dividing the brain into 2. And one hemisphere is used for put into fixatives, such as formaldehyde, to preserve it. And that's a good way to then be able to do some diagnostics on the brain. And then the other half we keep as frozen, so we would slice it up. And this would be used for a lot of the molecular research that comes out. Okay, so we dissect the brain into equal pieces. Again, this is a stylized, rushed version of what happens, and then in areas of interest, particularly in the deeper areas of the brain, can be dissected out for more specific research. The frozen half of the brain is then stored at -80 degrees indefinitely for so it's available for researchers. Now, this is an image, a slide of a real brain from our archival collection. And these types of stains, histological stains that we can do on the brain is particularly useful for diagnostics. And so here, this is just a diagnostic slide. And if we look into the microscope, we can see some of the types of proteins or parts of the brain that may be relevant to particular diseases. That's just, again, just a very quick overview of a brain donation process. If anybody has any questions about this, just feel free to ask in the Q&A QR codes on the columns as well, and Greg can ask that. Okay, so I'll hand back over to Greg, and I have some questions that have been asked through this link. I will ask them in an order of how people have kind of upvoted them. Okay, so Greg, if you'd like to come up and we can ask a few questions. Now, there are a lot of questions asked, so we won't be able to get through all of them, but we can, if there's interest, we can kind of collate these and publish an online version of answers to these questions.
We might alternate also in the room, so if you, I don't know, can so that people can hear online, we can want to.
Sure.
So I might open it up to the room if anyone's got some questions, and then Kane will go through some of the online questions, which I'm sure will be of interest more widely. Yes.
Question that is.
We'll just get you to use the mic.
Thank you. Hi, everyone. I had a question around the car crashes and the in relevance to the countries and the drinking.
Yep.
So it was quite specific around, like, China and India was the lowest, I think, at like 4% each.
Yep.
But not long after that was Germany and one of the other countries, I think Russia, at about 8 or 9%, which to me I was kind of like, oh, you picture Oktoberfest and you picture the Russian vodka.
Yes.
What is culturally occurring in those, or, from governance perspective, what is occurring in those countries that's different to Australia that they have such a lower incidence of car accidents?
Yeah, well, the Russia one, that escaped me, and I share your surprise. I think we're very much like the US, I suppose. We're almost exactly the same size as a US mainland. So we do have a car and mentality. I think if you ask people of my team, most of my team who are quite a bit younger than me, about their attitude to drinking and driving, they just wouldn't do it. They always have a plan B. Either someone's a designated driver, but if you ask the generation older than me and maybe even my generation, well, we might, and then if you then drill down, hey, look, how many drinks do you think you can have before your reflexes are affected? They'd go, I'm drinking quite a bit. I'm well practiced. I drive, all the time. I think I'm absolutely good on 5 or 6 or 7 beers. So I think those probably lead a little bit. Out in the country, what's your chances of getting caught? I think that always has to be factored in with the human condition, and we drive, in the country. So we, as I still think of myself as a sort of a country boy, we tend to drive quite long distances. And in fact, a friend of mine who was from the Innisfail type of area in northern Queensland, they used to talk about journeys in terms of how many cans of beer they would drink. So you'd have a 6-can of beer journeys up there. So, and for young males, but changing too with young females, there's a lot of emphasis through advertising put on, hey, you're not a real Australian or not a real bloke if you're not drinking. And of course they make those adverts extremely humorous, etc. So I think all of those probably go a long way. But as I also said in the one a graph that I showed is that particularly amongst young people, the amount of alcohol is drunk in Australia is starting to diminish. So that may also reflect that other thing that the young people are looking at. They don't need maybe the alcohol to enjoy themselves.
Great, thank you, Greg. Now, one of the top questions that people have asked, and so just by the way, these QR questions, if you did want to ask anonymously, these are anonymous if you scan the QR codes as well in the room as well. So does someone with alcohol addiction drinking excessively at a young age between 18 to 28 years old, then rarely drinks after this, increase the risk of dementia or Alzheimer's in older age? I'm going to say yes. Well, a little bit qualified, because if you do, first of all, the quick answer is yes. If you drink to excesses, you are probably going to damage your brain, but that may well be because you've damaged your liver. Let me just come back to one point. I'll come back to that point and then just answer the second one. But if you do abstain, as I've shown you, there is recovery of at least your white matter. The problem with alcohol in liver is that if you drink to excess and your liver becomes irreparably damaged, think fibrosis, and then terminally from that cirrhosis, then the stuff that's reaching your brain, including ammonia, is kind of very problematic. So the liver acts as a very large cushion by metabolizing alcohol and also kind of other products. So the brain starts getting hit with not only the alcohol but also neurotoxic. So that is a major problem. And in fact, in our brain bank, when we do have people that are abstained, they've often been abstained because a clinician, particularly liver or gastroenterologists, have said to them, if you do not stop, you will either need a liver transplant and or you're going to kill yourself, and you are not going to be well looked upon fondly as a potential liver transplant recipient, particularly if you're not showing any signs of drinking. So anyone who is on that liver transplant list will often have had to have shown quite a long period of abstinence and self-control to actually even get a liver transplant. Great, thank you. Regarding the amount of resveratrol from wine required to have a cardiovascular benefit, is it true that you'd have to drink such a detrimental amount of alcohol that the benefit is outweighed by the risk?
See, I like that question because there's a very quick answer, which is unusual for me. Yes, that is almost going to likely to be correct. And it does pain me to say that a little bit because my family, or that are back in New Zealand, actually come from a place called Marlborough, and winemakers. So I won't be popular in the wider family by saying that, but yes, but that would be correct.
Thank you. And also regarding dietary intake, would raising good fats in our daily intake assist with the white matter?
Yes. And the reason I'm relatively confident of that is because we know Western diets now also cause fatty liver and have recently, in the last 5 years, usurped alcohol as the major cause of liver disease. Because we've now got an obesity epidemic in Australia and other countries of the world, there is a lot of interest in it, and I think there's going to be an intersection of those two problems. And I think you will hear in a couple of years' time that fatty liver plus Western diet plus alcohol is doubly bad for the liver, and it's going to accelerate people who are having problems with their brain because of secondary to their liver, and those who are seeking liver transplants.
Great, thank you. Can you discuss how alcohol affects somebody's mood in the long term, specifically men?
Yes, well, I suppose with addiction, yeah. So mood, personality, very much associated with the front part of our frontal lobes or the prefrontal cortex. And we do know that that's an area that's affected by alcohol. When we talk about clinical manifestations of chronic alcohol intoxication, you would hear people talk about loss of working memory and loss of attention. And so talking to the clinicians and drug and alcohol services, they'll say that even if we get people into treatment, their organisation, particularly their compliance about taking drugs, etc., is poor, as is a lot of their ability to organise their lives. Sorry, just repeat the second part of that question.
Just how alcohol drinking affects somebody's mood in the long term.
Yeah, so I mean, mood is all in that same area of the brain. I suppose the thing, and this is conjecture a little bit on my part rather than knowing this as a point of fact, is that if you are not getting alcohol and you are addicted to alcohol, you will become extremely moody. But we also, in terms of short-term effects, we notice that a lot of people who do have a reputation for being moody tend to become quite nice when they've been drinking alcohol. Is there a relationship between alcohol and mental disorders which are associated with mood, i.e. the affective disorders? There probably is. However, there's also an issue around the direction of causation. And I probably alluded to it earlier that a lot of people do drink to self-medicate if they have these sort of common disorders like anxiety, but we do also see it with the more advanced disorders, major depression, schizophrenia, etc.
Great, thank you. There's a comment question that says alcohol and dementia a contributing factor.
Yes, well, funnily enough, I did also mention we work a lot on Alzheimer's disease. So this is going to be largely, we think, no, at least, and I think the image you showed down the microscope was looking at some plaques, was it? When we actually look at people who have had alcohol use disorder in their lifetime, they do not, in our humble opinion, have more of the characteristic plaques or tangles that characterise Alzheimer's disease. So that's kind of an equivocal. No, we do not think that there's a direct effect on Alzheimer's disease. But we do know that alcohol or long-term alcohol drinking can cause a related condition that we used to refer to as alcoholic dementia. We think the link between the two diseases might be that alcohol causes inflammation largely through those microglial cells that I was saying. So I have some collaborators in the US at the moment who are looking at those sort of connections and based in North Carolina. So there's definitely a connection there, but it's not a sort of a direct connection. And if you're talking Alzheimer's disease, probably not. So I wouldn't be advising people stop drinking completely to avoid any chance of Alzheimer's disease, but it's not going to help for a number of reasons.
I've got a brain banking question for you. Would having epilepsy make you ineligible to donate your brain?
Look, so it shouldn't, because epilepsy is one of the most debilitating conditions that you can kind of ever suffer from, and a lot of people were extremely young and have had to deal with it across their lifetime. So if we were a bank that was concentrated on epilepsy, i.e. we bank tissue to support epileptic research, we would have people with epilepsy. And at the moment, we're not. We concentrate on a couple of diseases and including controls. So the problem with epilepsy, as you can imagine, is that these periodic massive explosions of kind of excitatory waves in the brain, and then also parts of the brain called the hippocampus, or parts of the temporal lobe, actually can become almost fibrous, like I was talking about with the liver. And those are problematic for the diseases that we're kind of interested in. So short answer, it does exclude you, but we should be banking epilepsy tissue in Australia, and therefore it wouldn't. And we probably in the near future will become more of a general brain bank, because we certainly are not helping all of the organisations that could benefit from brain research.
Thank you. There's a question on alcohol dependence. So alcohol dependence has a unique ability to repair the brain after quitting alcohol. Has there been any developments with other neurodegenerative diseases or conditions that have a similar reversal?
Yeah, no, that's an excellent question. The problem with those other diseases, so if we take Alzheimer's, for example, which is the one I know about, so the two major factors, one is aging, which we can't stop, I don't think. Although, okay, so there's a certain number of people, and one might be over at UNSW, that suggest you can. Don't know enough resveratrols to come up, and this is sort of an anti-aging thing too. But let's say that, at least from a time point of view, you can't stop it. The other is a genetic common variant called apolipoprotein E, and having a variation, there's 3 different variations, but having one called 4. If you have 2 copies of the E4 variant, then your lifetime risk of Alzheimer's disease is somewhere between 50 and 60%. So the problem there is that neither of those things are anything that you can do something about. And so even if we knew what the basis of the white matter recovery is in alcohol, then those other diseases are sort of progressing along. But as I spoke about in my talk, I'm relatively confident, because white matter is, as it is in alcohol-related brain damage, it's also underestimated in Alzheimer's disease. And so if we can take advantage of how white matter recovers during abstinence, then there is a chance that even though we don't know the cause of Alzheimer's disease, other than those 2 factors, we can slow it down, which is probably the best that we'll ever do with Alzheimer's disease.
Thank you. If a man has been drinking excessive amounts for at least 10 years or more, being diagnosed with vascular dementia at age 70, but have now stopped drinking, will the disease slow down?
No, that's a very similar question. It's a similar question to what I was talking about. And vascular dementia, so across the dementia spectrum, there's Alzheimer's disease, accounts for probably 60 or 70%. And then the next 2 big types of dementia are vascular dementia and then a Lewy body dementia. And then there's some other entities too that are far less common. But vascular dementia is quite a difficult disease like stroke, like heart failure. All of the risk factors are very similar. So I would imagine if you stopped drinking, it's going to help, but you would also have to visit all of the other factors that might be driving that. And that could be like poorly or uncontrolled hypertension, and definitely look at your lipid profiles, the whole idea of dropping your cholesterol. So someone like that probably wants to be on statins or a statin combination drug, and also be handling their heart disease. And I have also gone against my disclaimer by talking about clinical things, but that's what I would be saying to them. Yes, it's going to help, but you would want to be doing a lot more to slow the disease substantially.
Thank you. How are we going for time?
One last question.
Okay. For all the interesting statistics on how many drinks people have, how is that measured? And if by self-report, and if so, how reliable is the data in terms of accuracy?
Yes. Thank you for that question. So scientists are really good at making, there's a significant difference. We're less good at revealing the sources of our data, but as the question alludes, a lot of that data is self-reported, and through potentially stigmatisation or poor memory or poor working memory, having drunk too much when you're just about to answer the questions, we are not good at recalling how much we drink. So we're almost certainly underestimating the amount that's being drunk, at least in some people. And a neurologist friend of mine, he reckons he returns to the drinking question 3 times in his initial consultation, and he nudges up the levels as he goes along. So that's also some anecdotal evidence that it's underestimated. Yeah. Just on that point too, and just thinking of Kane's work, there is a compound called Kane, getting the pronunciation right, phosphatidylethate.
Biomarker.
Yeah.
Oh my gosh. Phosphatidylmethanol.
Which actually is like BA, like blood alcohol level, gives us an idea if people are drinking up into there. So we can actually test within the last 3 months if people were active drinkers. That marker is also is a blood test too. So for certain organisations that do not fully trust their staff, they may use that just to check you out, as they might use breathalyzers and that. But it gives up to about three months as opposed to your blood alcohol concentration, which tends to drop by around about 7% every hour. So after 24 hours, you've just about washed it out of your system. Yes.
So sorry, last question. Just really.
Okay, and then I'll.
Yeah. Sorry. Just regarding, I know the 10 drinks per week.
Yes.
In Australia. Is there any research, or is there any interest in seeing, low to moderate, like changing those low to moderate safety recommendations for alcohol, especially with so many people deciding not to drink anymore? Is there any, I don't know, is there any concern that 10 drinks per week
is too much?
Too high? Yeah.
Yeah. So the question, just for the people online, was whether the guidelines of 10 drinks per week is too high. I just to again come back to the World Health Organization, who now consider there's no safe level of alcohol drinking. I think we will see those guidelines tighten again in Australia. What's holding them back at the moment? Well, I think there's a little bit of libertarianism, which we hold very close to our hearts. We don't like to be told what to do, and we can often vote against that. And there's still, as I don't want to say, but there is still a very big and powerful lobby that suggests that alcohol is part of the Australian experience. And so anyone who is trying to get those things changed or guidelines is facing a bit of an uphill battle, particularly to get political will in behind that. NHMRC would generally be regarded as being independent of those and their experts, but I think if there are any retarders on us changing those guidelines, those would be the kind of ones I would be thinking of. Okay. Well, with that last and excellent question, I think I'll wrap up today's webinar. Thank you for the people online who have joined us. Thank you for the people in the room. A big thanks to the Brain Foundation for organising such amazing events during Brain Awareness Week. There's still one webinar to go tomorrow, and that is, Anik, what is going to be on?
So tomorrow's webinar, for anyone who is attending in person today and hasn't signed up online, there is still time to sign up. It's a migraine Q&A session with neurologist Dr. Michael Eller, who's a headache specialist. So it's an opportunity to basically ask any question that you want, things that you might not have time for in a normal doctor's appointment. So we hope to see you there online tomorrow. And thank you so much for attending this session. And
how do we join that?
It's just on Zoom. The link to the registration is just on our website. brainfoundation.org.au is where you can sign up. Yeah.
And I should quickly add, alcohol is a very common primer for migraine. So there we go. There's a connection there. You said we don't take advantage of segues in academia. Thank you, everyone.